Right. So here's what we need, right? We need to develop something called a parametric equation, right? Let's look there. Right? We need to develop a parametric equation. So we need to introduce a next variable. Um, Alright. So right? So we need to be able to write the equation of a circle and introduce a new variable. Alright? So I'm gonna start with something simple. Let's start with a simple circle, right? Let's start with a simple circle. You'll see that? Let's start with a simple circle with a center 0, 0. Look at that one line. Right? A simple circle with center 0, 0, radius r, right? And a point on the circle here, x, y. You'll see that? Right. So we're going to attempt to get an equation that looks like this, right? But of course, if the center is 0, 0, then the equation is really what? Here is 0 and here is 0, right?
Yeah.
So it's x squared plus r squared is, sorry, plus y squared is r squared.
Yeah.
So we are going to attempt to get that here. All right. So inside here, I'm going to construct a right angle triangle. Does it not too small?
Wait, so what module we on?
Module 2 cell.
Alright.
We finished trigs and we are in geometry now.
So we're going to be back to the
After geometry.
alright, done.
All right. Polygon SPM module 2.
No, but we passed this now. It's not module 2, but we on.
Yeah, only I had here.
We almost done check this.
All right. So watch this here. Let's just do that. Right. So watch this here. So we are going to develop an equation, and within that equation, we are going to introduce the new variable theta. All right. So watch this here. Based on this diagram here, what's this length here? Based on this diagram, point being x, y, what do you think this length is here? Enough? And here will be x, here to here is x, and here to here is what? Y. Are you okay with that? So if I use trig ratios, what will I get in terms of y? I'll be able to get what? Sine theta is equal to opposite over hypotenuse. So I'll get y over r. So I'll get y is equal to r sine theta. Right? And if I do here's x, right? If I do it in terms of cos, I'll get cos theta is equal to adjacent and hypotenuse, x over r. So x is equal to r cos theta. You okay with that? So therefore, the parametric with this circle, right? The parametric with this circle, center 0, 0, and radius r, the parametric is this. Right? This is your parametric. X is equal to r cosine theta. Y is equal to r sine theta.
So,
Yes, sir.
when you like great.
Well, I'll leave that page I want to put on. When you follow how I went wrong, that's right there.
Get a draw arrow.
All right. Okay with that? So if you see something looking like this is the parametric circle. Okay. Ready? Right, so when I finish, we're gonna take this parametric, remember parametric equations are x and y in terms of some new variable, right? So we're gonna take this simple parametric and find the Cartesian. You all seen it as a circle? Jacob? Seen it as the circle? What's the radius? We can watch it right now. Watch it sound. What's the radius? Right, so if you look back there, you'll be able to identify what's r and theta, right? Sorry, center and r. But just in case you don't, I'm going to show you how to go from here right back to the equation of the circle, right? But remember what to do? No. No. All right. So when you're here, let's say you didn't identify that this is the same as the parametric for a circle with 0, 0 and center 0, 0 and radius r. Let's say you didn't recognize that. What you could do here is you could make cos theta the subject of the formula. Cos theta is what? X on 3, right?
Yeah.
And sin theta is what here? Y on 3. So if we remember that cos squared theta plus sin squared theta is 1. Remember this? Yeah? Right? You'll just get it wrong there, right? Cos squared plus sin squared is 1. We could take this and put it in here. We could take this, put it in here. Correct? So you'll end up with, if we substitute, you're going to get x on 3 squared plus y on 3 squared is equal to 1. Right? So if we substitute to cos theta and sin theta, it'll look like this. And you'll be left with x squared on 9 plus y squared on 9 is 1. Does it look like a circle? Right? Not looking like a circle as yet, right? So what is it to make it look like a circle? No, just multiply it by 9. Multiply by 9 and you'll get x squared plus y squared is 9. You recognize that?
Yeah.
So it could be written like this: x minus 0 squared, y minus 0 squared is 3 squared. All right? See that? So I just get rid of the denominator, and then this is the equation of a circle. Center, 0, 0, radius, 3. Are you okay with that? Right? So in case you don't remember this, all you have to do is make cos and sin the subject and substitute an identity. That's okay? In this case, this one. It all can actually for circles, but that's the one. Right, but of course it wouldn't be that simple, right? It wouldn't be that simple. So let's complicate it a little bit. Huh? You didn't write this?
All right.
Oh, sure. Well, I'll leave it there. I'll leave it there.
Okay.
I know you figure it out.
Because that guy is not that you must mark. Save block.
So, nah. Ready? Ready?
No, yeah, go on.
Right, so all I'm gonna do now, I just wanna change it, right? Because you won't really see, you'll hardly ever see the center being 0, 0. I'm gonna change the center to our next point. Okay? Okay, about this. We can have this right. All right. So let's say I give you a next circle. The center is E and H. Right? The center is E and H. And there's a point on the circle. That point is XY. We're going to try to develop the parametric equation for this circle. Same principle. We're going to create a right angle triangle here. And we're going to call here theta. Real simple. All you gotta do is figure out what this length is and what this length is. All your hard work finish. Because the radius here is still out. Right? So Jesse, what do you think? What do you think? Seems right similar to what we had before. What do you think the length of this line is? You sure? Remember, if X is here, this whole thing is X. Yeah, I can't now. Here is accent. This whole thing is accent. And here's how much. If I draw this down, how much is here? If I draw this down, how much is here? So here's E, here's X. How much is here? X minus E. Good job. Right? So, Keisha, how much is here? Here's X minus E. So how much is here? Y minus each. Nice. Y minus each. Okay? You can do more favor and do the same thing as before. Find cos theta, and find sine theta. And tell me what the parametric equation is. That's all. Do the same thing fast. Online, any questions? Feel free to ask, right? Aliyah, are you okay there? Yes, sir. How that's how I'm gonna do that. You know what needed? They don't need it. You ready? Yeah, yes, we should do it. Right. Raj, Raj, you there? Okay. We'll get it out, right? Right, to find the parametric equation in both cases. Right, cos theta adjacent and radius. You're looking, so, sorry, make x the subject, right? And make y the subject. Accurate? Right, so here, right, when you cross multiply, you'll end up with x minus a is equal to r cos theta. When you make x the subject, you'll get a plus r cos theta. That's okay? And then sine theta is equal to opposite over hypotenuse. When you make y the subject, you'll get something very similar, right? Y is equal to h plus r sine theta. All right? So these are the two parametric equations of a circle, right? These are the two forms that you do. That's okay? Yeah, Victoria? Right? So if you see this, right, the value in front of cos and sine the same, that is a circle. Okay? So once you remember that, you should be able to read off R and it should be able to read off center. You're saying that there? So the center here is what? A and H, and the radius is R. All right? So I'm going to give you an example here, and all I want you to do is tell me the radius and center. Right? All I want you to do is tell me the radius and the center, right? So let's try a small example. X is equal to 4 plus 3 cos theta, and y is equal to minus 2 plus 3 sine theta. Right? These two parametrics are what? It's a circle, right? You're seeing the relationship?
Yeah.
Which is good, right? You're seeing it? You're seeing that these two are parametric, right? Yeah? So if I ask for the Cartesian, what is the radius? Based on this form here. Whatever in front of cos, right? Or whatever in front of sine. That's okay? And the center is what? Center is AH, so that's 4 minus 2. You're okay with that? Or get what? You sure?
Yeah.
Right, but I have to the Cartesian. So you still have to write it like this. X minus 4 squared plus y plus 2 squared, because there's a minus here, is equal to 3 squared. Have it? Double? You sure? Right, so I put it in the form there for you, right? You okay with that? Alright. So I take this and I put it in this form. But suppose you don't remember it all, yeah? What to do, Jacob? Suppose you don't remember this in exam, but they ask you to find the Cartesian. What would you do? Right, make cos the subject and sine the subject, right? Nice. Good job, Jacob. Same thing, right? Find the Cartesian here for now. Try that, please. Try number 2. All I want the Cartesian. All I want the Cartesian. That's for this one. And the Cartesian.
It's center was 44.
That's right.
I think it's only one of the best 8 inch. Yeah, it radius is 4. I see, I listen, that's good.
Right, please remember to make exit subject before you start working it out, right? We find the Cartesian of that too. Right, so when you get the center and the radius, find the Cartesian, right? So make x the subject here. You'll get 4, sorry. If you make x the subject, you'll get -2 plus 4 cos theta. And here, you'll get y is equal to +1 plus 4 sine theta. Right? And all your hard work finished. Right? Center, the center is -2, 1, so that'll be x plus 2 squared plus y minus 1 squared. Radius is 4, so you write 4 squared. That's okay? Center, radius. Everybody okay with that? Right? So let's change from this shape, right? Suppose tomorrow. Suppose I give you a shape, right? But the radius not staying constant. Right? So suppose I give you a shape like this. You have a center, but the radius not staying the same. So at this point here, that's the radius. At this point here, it get a little bit smaller. At this point here, same thing. At this point here, together. What I will shape, what I will map out. So here, and then again smaller here. Then again smaller. Okay, back bring here.
A lens.
A lens, or what we call an ellipse.
Yeah.
Right? So this is an ellipse. All right. So what you will recognize here is that the radius not staying the same. The radius large here, and again smaller and smaller. Okay? So whenever the radius is not the same, we have a new shape. Darian, so I have to take a phone. What is this? What is it called it? A what? Right? This is called an ellipse, right? So we're going to focus on this shape now. Okay? Right, I'll give you Lucas land, right? Let us spell that wrong. Right? That's clear enough. All right. So let's take a look at an ellipse. Ready? right? So an ellipse generally looks like this, right? Right? You have two types of ellipse. I'll do the first type. The ellipse at the center, right? Let's say the center of the ellipse is AB, right? The center of the ellipse is AB, and what you will recognize in an ellipse, the general form Did you find it like ellipse? All right, don't fix it before I laugh at my thing again. And when you laugh and say I can't draw. I'll try my best. I try my best. Huh? Right. So here we have an ellipse, right? As I said, an ellipse is very similar to a circle, except that it doesn't have a constant radius. The radius can change it, right? So the parameters that define an ellipse is a little bit different to a circle. If you want to define a circle, you just need two things, center and a radius. But to define an ellipse, you need something different. Anybody knows what is called it? What are the parameters that you use to define an ellipse? The close it. All right, that's someone you close it. All right, anyway. So the general form for an ellipse looks something like this, right? Right, the general form looks like this. X minus let's use h. Hi. Like F on H. Before H is what? Let me see. G. Right? So the general form for an ellipse looks like this volume. X minus a squared, sorry, g squared all over a squared plus y minus h squared all over p squared is equal to 1. That is the general form for an ellipse. It's a little bit different as circle because these values here are not the same. If these values here are the same, we have a circle. Right? If these values here are the same, we have a circle. They are not the same, so what we have is an ellipse. Right? So G and H are our center. Right? The center is G and H. And so in this question here, G and H is 0. So the equation of this ellipse is x squared over a squared plus y squared and p squared is 1 squared. Well, believe it as 1. All right. So how you just watch an equation and know it's an ellipse? These values underneath here are not the same. If it's a circle, they are the same. All right. So this is the general form for an ellipse, and this is one version, right? Right. I want to give you some definitions there, right? Go ahead, quick now. Finish? Finish here? So this is an ellipse, right? In this version of the ellipse, you'll recognize that the value B is bigger than E. And if the value B is bigger than E, then in this version, we call the y-axis, we call that the major axis of the ellipse. And because A is smaller, we call the x-axis the minor axis. Right? So we have a major and a minor axis here. Okay? What would have happened? What do you think the graph will look like with the same thing? Center 0, 0, but A is bigger than E. Right? It will kind of rotate 90 degrees, right? So the graph might look something like this. Right? So it might be shaped something like this. Right? Of course, you just try and get a little smoother, right? But here, same equation, except that the major axis is which one? X. The major axis is the x-axis. And the minor axis is the y-axis. Right? Just make it a little smoother for now. Right? Same equation. X squared on A squared, y squared on B squared is 1. Right? Catch it quick, and I want to give you a small definition, right? Anyway. Ready? Oh, there are two items there. Two.
Eclipse.
Or the driver job or online, you know it myself. Right, so I just want to give you, there are two special points that are missing on our ellipse, on our ellipse, right? Two special points that we call the foci.
Okay.
Yeah. Now, okay, I note down. Right? There are two, write this please. There are two special points. There are two special points that are equidistant. There are two special points that are equidistant from the center. There are two special points that are equidistant from the center on the major axis. There are two special points equidistant from the center on the major axis called the foci. All right, so what is here? For this one here, this is the major axis, right? This is the major axis. So there are two points equidistant from the center, C and minus C. These 2 points are the foci, right? Those are two special points that we have on the circle, on the ellipse, right? That are equidistant from the center and always on the major axis. And we have to be able, when we write in the definition, we get on the center and we get on the foci as well. Okay? How to find this? How to find the foci? The foci is equal to, in this case, B is larger than A, so it's B squared minus A squared. So C squared is B squared minus A squared. So to find C using this formula here, right? You can set up a little Pythagoras theorem and work it out, right? And here, what do you think C squared is here?
This one be A.
Because A is larger, right? So it will be A squared minus B squared.
Yeah.
Right? That helps you find this special point here, C, and this special point minus C. Right? These are two special points on the ellipse. Right? Just like how you have a center and radius, the special point on this is the foci. And I will show you when we do locus why it's so important, right? All right. Let's see if we can sketch. Let's see if we can sketch x squared on 2 squared plus y squared on 3 squared is 1. All right. Let's see if we can sketch this. Right? So before we work it out, anybody can tell me what is A? A is, okay, first thing, what is center? Look at general for me. Right? Center is what? So the first thing you'll recognize is the center is 0, 0. What is E? 2, easy to read off, right? What is P? 3. That's okay? So therefore, C is what? Which one are we using? This or that? That's very good. B is bigger than A, right? So we're using the square root of 3 squared minus A squared. Sorry.
3 squared minus A squared, yeah, sure.
3 squared minus 2 squared. Right? So that is square root of 9 on 4 is root 5. Are you okay with that? So we know C, we know A, we know B, we know center. Who has the major axis? B, right? So the y-axis is the major axis, right? So we do a little thing here, a little sketch quick. Center is 0, 0, so we're good to go. This is 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. This is 3 minus 3, 2 minus 2. Right? So A is 2, B is 3. So I'm plotting up here. I'm plotting up here for you. And I'm going to connect it up. Right? It wouldn't be perfect earlier. If you use your ruler, I'm thinking it might be better. And what missing? Very important. On this ellipse, we need to write C. C is root 5, right? Root 5 is how much? 2 point something? 2.2. So where would C be? Where would C be? Y-axis or x-axis? Right? Remember, the foci is on the major axis.
Yeah.
So B is your major axis. Right? Basically, see which value larger. Okay? So therefore, your foci will be here. What is it? 2.2? 2.2. So I'll put C here. And I'll put minus C here. That's okay? I showed the value here, right? So just put C there, plot it. And that's it. Okay? Plot it and you're good to go. Everybody okay with us? Up and down, let's go again.
They found out it wasn't God's way.
Catch this fastly. 4x squared plus 25y squared is 100. We have a slight problem here. We have a slight problem here. Does this look like number 1? No? It doesn't look like number 1 now. Right? I pick somebody online and let me see who could help us.
Okay, so which one number one? The example?
Yeah, number 1 is the example here.
The one
Bradley. Sorry. This example here, number 1, doesn't look like number 2. How to make number 1 look like number 2, Bradley? Sorry, how to make number 2 look like number 1? Bradley?
Nah, so I good.
Is it?
Yeah, I good.
Right? We have one slight problem, a big problem. Well, not big problem, but one thing at a time.
Say, listen, I'm one of them.
Now,
Yeah.
something we have to do.
Wait.
Yeah, figure it out. Divide by 100. You have to make the right hand side 1. Right? Go ahead. Divide by 100 and divide by 100 and sketch it back. Walk along that way.
Sir, your that not intense, sir.
I let
With the sound of all, it's so serious. I'm so serious. Nah, it's so serious. No, you can't sound that fun.
Should we think quick now, boy? So yeah, come back. So yeah, come back.
And then like I want to, I'm not doing it. So like me, like I want to do it. See if she wants to do it. Like she did. I don't know. I don't like he graduated or like on in front person, right? Then we drive out was cold and something. We could get, and it was like, well, she was like she was sweet, like, I was like, come on. And then I was like, I didn't want to do some walk, like, continue.
You walk away.
And I'm like, I continue walking, and then I like reach far, right? I reach my ground, and I hear around, like, I come around all the street, because before I went here, there was a truck, and you know, hitting the street, and I was fast, so I was like, nah, I'm fine. So I'm going about.
You went back out there.
I'm going about the whole month, and I'm like, the street right outside, and like, this lady, just, you know, I don't know what to do. Like, they can help. This one said, okay, I will try. No, that was the next one. Right?
Alright, so he was this one.
Wait, I know the story, no, but- No, I didn't know where I did it.
Speech in a voice, don't lie.
Big street. Okay. There's this such a. And like the lady of the time, he did not why not the car on the front of it. And I keep going inside, working out. And like he wanted to take out the garage, so we took our dog. And then like I guess you say I'm.
Shut up to that, sir.
No.
Every guy, come on.
And then. Yeah, I called the police and I get called, so I was like, you know what?
Alright, now it's on it, comes up. Next week. Now you're gonna shove them.
You're gonna put on hold until somebody's available. Yeah, I was like, you know, my next best hope is to run till that song, we gotta run.
How do you want
So it, you know, like, when you see the number, then you're gonna get around. No, but hey, you gotta see it, you gotta see how, you know, last name, right? You gotta see orange. But it's like, okay, come in now.
Alright, come on, let's finish up this way. Right, so divide by 100, what you end up with? X squared on 25 plus y squared on 4 is equal to 1. Right, so put it in the form x squared on 5 squared plus y squared on 2 squared, right? Where is the major axis? Center is what? Right? Center is 0, 0 because there's nothing on top here. A is how much earlier? A is 5. And B is what? B is 2. And C is what? C C is the square root of 5 squared minus 2 squared. So that's the square root of 21. Right? So you do your little thing here. Minus 5, 2, minus 2. Where does C belong again? Which axis, Shivish? Which axis does C belong? C belongs on the major axis, right? Okay. So that is your equation. That's okay. And you have the value for C, right? Sometimes they ask you to write the vertices. So when they say write the vertices, just write the point here. The point here is 0, 2. Point here is 0, minus 2, and so on, right? Okay. They actually go to field. You know what? I'm gonna not call it still. I know we don't have much time. Look back at the parametric equation of a circle with centers 0, 0. Right? Look back at the parametric for a circle with centers 0, 0, and see if you can help me get the parametric for an ellipse. Darian, help me out now. Look back at the parametric for a circle. And see if you can help me figure out the parametric for a ellipse. With center 0, 0, right? Yeah, Diane, what do you think?
You got today,
Parametric for a circle we did actually. That's the first thing we did.
That's it.
Yeah.
0, 0.
Whatever you, so
Equal
for-
R plus
yeah. So for a circle that R plus theta, y is equal to,
R sin theta.
right. What do you think it would be for an ellipse?
R tan theta. I tried.
Diane, would it have an R? There's no radius for an ellipse, right? So what do you think it might be? What corresponds to X? X squared over
E.
E. So it will look like this. Right? It will look like this. Okay, and in general, it will be X is equal to what letters I use again? G and H? Yeah, use G and H. G plus E cos theta and Y is equal to H plus B sin theta. Right? This is in general, right? This is with a center, sorry. This is with a center GH. All right, so these are the parametric equations for our ellipse. Right? Very, very similar to a circle, except that these two values here are not the same. If these two values in front of the trig are the same, then it's a circle. Each story take out 7 minutes. Some of them. Thank you very much. I do what? Make it front page? Guys, what they can do? Alright. I don't